So precalc chapter 5 section 2, we're going to look at how to verify some more trig identities here. And when we're looking at verifying, the first thing I look for is the opportunities to complete the algebra. So that's factoring, adding fractions, squaring binomial, create monomial denominators, or some of the skills we've talked about in the past that you're looking for the opportunity to complete. We also want to be able to use identities to manipulate the one side to make it equivalent to the other side when we're verifying. So an example, let's start with this example. So we have 1 over 1 minus cosine b plus 1 over 1 plus cosine b. So right away I see the algebra here is to add the two fractions. The right side doesn't have any addition of two fractions or addition of two quantities. So I want to try to add these to get down to one quantity. And so to do that I need to have the common denominator, so I got to multiply by 1 plus cosine b to the numerator and denominator of our first fraction. Now we got to multiply by 1 minus cosine b to the numerator and denominator of our second fraction. When we do that, our denominator becomes, if I multiply these two together, it's going to be 1 minus cosine squared b is our denominator, our common denominator. Our numerator, when I multiply this first one, we get the 1 plus cosine b plus 1 minus cosine b. We still have the equivalency here. So then we have, on the numerator, we have 1 plus 1, which is 2, and a cosine b minus cosine b is 0. So you have 2 over, and then this quantity here, 1 minus cosine b, we should start to get familiar with these Pythagorean identities. The 1 minus cosine squared b is going to be sine squared b. And our last step is to rewrite the over sine squared b is cosecant. So this is going to be 2 times cosecant squared b equals 2 cosecant squared b. So that'll be verifying. So we're looking at the algebra and then some of the trig to help us verify. Secant squared x minus 1 using our Pythagorean theorem over here. So if I do secant minus the 1 is positive tangent squared x. And then sine squared x minus 1 is actually equal to negative cosine squared x from Pythagorean theorem as well. So then tangent, I know there's a relation between tangent and cosine, so tangent squared is sine squared x over cosine squared x, and multiplied by a negative cosine squared x. And so we have some reducing that goes on there. So this cosine squared x, we reduce it with this cosine squared x, so we have a sine squared x times negative, which is negative sine squared x equals negative sine squared x. So for this one there wasn't much algebra, it was more dealing with the trig identities. So this was a little different. From 5.1 we should see that the 1 minus cosine b in the denominator, we have kind of an algebraic way of getting rid of that denominator to rewrite this without having a fraction. And so that's one of the skills when I see within problems I try to use. So I would multiply the bottom by 1 plus cosine b and the top by 1 plus cosine b. So notice how I'm using the right hand side and we'll leave the left hand side alone. And you can do it the other way. You can manipulate the left hand side to equal the right hand side, it still works. So on the left hand side we're going to keep that the same. On the right hand side you would have, if I multiply the denominator, I have 1 minus cosine squared b, and then we have, if I distribute, it's sine b. Actually I'm not going to distribute, I'll leave it sine b plus cosine b for a second. And so on the bottom, that bottom is negative, actually is sine squared. So we have sine b times 1 plus cosine b all over sine squared b. So we have some reducing here. And again, the numerator is multiplication, the bottom is one term, so this sine b reduces with one of these. So now we have cosecant b plus cotangent b equals 1 plus cosine b all over sine b. Now we can use some of our algebra that when we have a monomial for a denominator, we can divide both of those terms by that monomial. So this would be cosecant b plus cotangent b equals 1 over sine b plus cosine b over sine b, which now we have it. So we have 1 over sine b is cosecant b plus cosine over sine is cotangent b. So that verifies. Okay, next one here. So a similar setup here where we have tangent squared over 1 plus secant, and we have 1 minus cosine over cosine. So we can manipulate this again. Left side here. So I have 1 minus secant and 1 minus secant. If I do that, so we have tangent squared theta times 1 minus secant on the numerator. The denominator, when we FOIL that, we get 1 minus secant squared theta. Now notice how they started off with the denominator just secant, and then now when we FOIL that, we get secant squared, and that's what we need to use Pythagorean identities. These identities only work when we have the squared values. So we still have 1 minus cosine theta over cosine theta. So we have 1 minus secant squared theta on the denominator, and so if we look at our Pythagorean identities again, we have the 1 plus tangent squared theta equals secant. And so the relationship here is close to what we see here. And so if you don't quite see it, you could take the tangent squared and rewrite this tangent squared as that is secant squared theta minus 1. And we still have the 1 minus secant theta, and we still have it over 1 minus secant squared theta. So now these two, the numerator and this first quantity, are just opposites. So if we factor out a negative, pull out a negative 1, and it changes the sign of these. So that makes that negative and this positive. So now those two quantities are the same. So now these will reduce out. And then I'll end up with the negative 1 times 1 minus secant theta. So we reduce some stuff out, but you really can't see how it helps out a whole lot. We can rewrite this as negative 1 times 1 minus secant is 1 over cosine theta. So now you start seeing the cosines we needed in the problem. And so we can distribute the negative back through here as a negative 1 plus 1 over cosine theta, and then we actually need to add these two fractions. So if we're going to add these fractions, we can rewrite this first fraction as a common denominator. So this is going to make a negative cosine theta over cosine theta plus our other fractions in the problem, 1 over cosine theta. And now we can write this with one denominator, which ends up being the same thing. If we just rearrange the order to write it, we're going to put this 1 first, and then minus the cosine theta all over our common denominator, cosine theta, and we got it. So I think this is a difficult one to see as you go through the process, but it still works out. So these are some examples for how to verify, and that's really all we're going to be doing in 5.2, a lot of verifying, and then we're going to add some new identities in the next few sections and continue verifying using a lot of these same skills. So have a good night.